This lecture we'll talk about making a program, a Python program, that actually has a graphic user interface so the user can interact with the hardware directly through some nice graphic user interface. And this is interesting because it's something you can do on Raspberry Pi that is interesting, and you can't do it with something like an Arduino, not easily anyway. So a graphic user interface is basically a user interface that uses pictures somehow, right? And we've all seen graphic user interfaces, point and click, buttons, pull downs, that sort of thing. So you would like to be able to use a graphic user interface you might like to be able to use a graphic user interface to access the general purpose I/O pins. Now, of course, you're going to have to write some code, write some Python code for that. But then, once you've written that code, the user can interact with the pins, make things happen on the pins, and communicate with other devices by interacting with a graphic user interface. So they'll see something on the screen, some kind of a user interface, and click and point and type and stuff like that, and make something happen. Okay, so that's the goal here, to define some program that has a graphic user interface. Now, Raspberry Pi does it, Arduino doesn't. So this is one of those things that's different, that distinguishes Raspberry Pi from Arduino. So the stuff we've seen for the last few lectures, talking about accessing GPIO, making pins high and low, and pulse width modulation, and so on. All those are things that the Arduino can do just as well, maybe better in a lot of cases. But they don't really leverage the operating system at all. So GUIs, graphic user interfaces, that's one of the advantages you get from having an operating system. That the operating system supports, you can talk to the HDMI, talk to the keyboard, talk to the mouse, and it can provide you with this graphic user interface. Right? Linux allows that, right? It supports that. So why not use that, right? So this is one of those things that you can do with Raspberry Pi that because it has this operating system support that you couldn't do with a regular Arduino, not easily. So when you're making a graphic user interface, you are typically the user interacts with widgets. Widgets are some kind of visual entities, something that the user can interact with. Now you know what these are intuitively, you've seen these before. Buttons, menus, sliders, scroll bars, all those things that you see on the screen that a user can mess with. Drawing surfaces for drawing, you can put a drawing surface and a person can draw into that. So any kind of graphic way that a user interacts with the screen, those are called widgets, so lots of different widgets. And what you want to be able to do, for one thing, is to put these widgets on the screen, right, in a Python program. So write a Python program that places widgets on the screen for you and allows the user to interact. Now, the execution of the code, when you're talking about one of these graphic user interface programs, is typically not completely controlled by the programmer, but by the user instead. So what that means is, the programmer writes code. And the code, it lists a bunch of lines of code that execute in a certain sequence, right? And with a regular Python program, everything, the order is completely controlled by the programmer and the data the programmer receives, but the programmer writes a sequence of instructions and determines in what sequence they will execute, right? And there are options, if-then statements, it might execute in this sequence or that, but the programmer is in control of that by the way they write the code. Now, with a graphic user interface, what happens is that the code that gets executed is determined by what the user does in the interface. That is, if the user clicks on one button, then one function gets called. And if the user clicks on another button, then another function gets called, right? So which function gets called isn't completely under control of the programmer, right? In a regular Python program, you can have an if statement. If this is true, then call function 1. Else call function 2. Right? And then the programmer determines, okay, one of these two things is going to happen. But with a graphic user interface, these functions, their execution is controlled by the user and what they do. Maybe they move a slider, and then this function gets executed, and so on. So that actually makes coding somewhat harder for the programmer because you can't predict the control flow sequence as well, right? You don't know exactly maybe the program's going to press this button 100 times, right? You don't know what random sequence they're going to press, and you have to accommodate all possible sequences. So in general, it makes programming more difficult, but you get a graphic user interface, and that's a good thing. Okay, so often graphic user interface-based programs are written as one big event loop. Okay, and this is simpler than it sounds. Typically, the program waits. It just sits there waiting for the user to interact with a widget. Okay? So it doesn't do anything. It just sits there statically. Maybe it does some initial stuff, but it puts a screen out there, and it sits there and waits until the user does something, types something. And when the user's not typing anything, clicking anything, then the code's not doing anything often. So the user pushes a button or selects a menu item or something, right? Draws something, grabs the slider, does some event. Okay? Now, when the event happens, you do something in response to that event. So when that event happens, a function is called. So when you say do something in response, you typically mean execute a function. So in some place in your code, in your Python code, you're going to have to associate these events that the user could do with functions that you want to execute, right? So somebody clicks on this button, this function is executed. They move this slider, this function is executed, and so on. So you do something in response. You call this function, you execute the function. Then, after you're done executing the function completes, and then you wait for something else to do. So you, again, wait until the user interacts again, and then when the user interacts again, you do the appropriate function. So that's the event loop, right? You sit there, you wait for an event. When the event happens, you execute the appropriate function, and then you wait for the next event. Thank you.